Welcome to the deep dive. Today we are plunging into the world of essential
That's
oils.
right.
We've got this really detailed document in front of us exploring, well, everything from their huge variety of uses to the nitty-gritty of their chemistry and potential risks.
Quite the stack of material, yeah. Really highlights just how much more there is to understand about essential oils beyond, just how they smell.
Exactly. And our mission, as always, is to kind of cut through the noise, pull out the most important insights, and give you a clear understanding without getting bogged down in every single detail.
Sort of the highlights reel, but with the important context.
Precisely. Think of it as your shortcut to being well-informed on essential oils. Okay, let's dive in.
Let's do it.
So one of the first things that really stands out from this material is just how widespread essential oils are globally. They're not just niche products, they're like significant trade commodities.
Absolutely. And their applications are incredibly diverse. We see them, of course, in perfumes and cosmetics, that's obvious, but also in foods, soft drinks, alcoholic beverages,
Yeah.
even toothpastes.
Right, toothpastes. Plus, this document mentions they show up in topical pharmaceuticals, incense, and even cigarettes.
Cigarettes, yeah.
And let's not overlook their long history in traditional therapeutic uses for, well, a whole range of ailments.
Yeah, and it also touches on some applications you might not immediately think of, like using them for food preservation,
Hmm.
supporting health in farm animals, and even in agriculture as pesticides.
Wow, pesticides. That's fascinating. The material also highlights aromatherapy as a rapidly growing application.
Yes, defining it in this context as the therapeutic application of essential oils and aromatic plant extracts used holistically to support physical, emotional, and mental well-being.
So basically, using these oils for therapeutic purposes.
Pretty much, yeah, in a nutshell.
Got it. And in terms of how they're used, the doc says they're typically applied to the skin, but notes they can also be taken orally, inhaled, diffused through the air, or used in other ways.
So a truly broad world of application.
Definitely.
Okay, so moving from how they're used to what they actually are,
Yeah.
this source goes deep into the many, many factors that influence the final composition and quality of an essential oil. This is where it gets really interesting.
Yeah.
It's not just about the plant itself.
Right. It's like a whole chain of influence, isn't it? From the field all the way to the bottle.
Precisely. The material breaks it down nicely.
Yeah.
First, you have factors related to the plant itself. The specific species, the cultivar, even the variety can make a difference.
Okay.
Then there are the environmental factors, things like climate, soil conditions, how much water is available, fertilization,
Yeah.
all that stuff.
Right. Where it grows.
Exactly.
Yeah.
And harvest and post-harvest conditions are also critical. So when you harvest the plant, which part you actually use, how long and where you store it before processing.
Mm.
And even if you dry it first, all of that impacts the final oil.
And crucially, the mode of production matters too, right? Like lab versus big commercial plant.
Yeah, absolutely. An oil produced in a small lab setup might be different from one made in a large-scale commercial steam distillation plant. The scale and the equipment, they matter.
And then there's the analysis itself.
Adding another layer of complexity is simply how the oil is analyzed. Different methods might pick up different compounds or measure them differently.
Yeah, I can see that. The document points out a specific challenge too, particularly in some developing countries where production facilities might not have the precise equipment needed to control things like steam pressure or temperature during distillation.
And that can lead to a lower quality oil even if you started with perfect plant material. Too much heat, too little cooling. These things change the oil's chemistry significantly.
Right, right. Speaking of chemistry changing, the document transitions to a really important aspect. What happens to oils over time and the potential health implications, especially around allergic reactions. We're talking about aging here.
Yeah, aging,
Yeah.
which is essentially the oil undergoing chemical changes like oxidation,
Yeah.
where it reacts with oxygen in the air,
Okay.
especially when it's stored improperly. Too warm, exposed to light or air.
And aged lemon oil is used as a specific example, isn't it?
It is. Turns out compounds like lemon, terpentine, citral, they decrease over time,
Okay.
while others like p-cymene and some epoxy compounds, they actually increase. And the concentration of p-cymene in lemon oil can apparently be a marker for how old or degraded it is.
Interesting, like a freshness indicator almost.
Kinda, yeah. And the main problem with this aging, it leads to the formation of peroxides and hydroperoxides.
Which are highlighted as potentially strong allergens. Okay, this seems like a key takeaway. Some basic components in fresh oils, things like linalool or limamone, might be weak allergens themselves.
Relatively weak, yeah.
But their breakdown products, the stuff that forms as the oil ages or oxidizes, are far more likely to cause sensitization and allergic reactions.
Exactly. That's a really crucial point. The oxidized compounds have far stronger sensitizing capacities.
And this directly relates to known contact allergy issues. The document points to tea tree oil and turpentine oil as like classic examples where these oxidation products are well-known causes of contact allergy.
Yeah, those are often cited.
And allergic contact dermatitis, which is basically a skin rash, is a general concern with essential oils. The document notes some severe reactions too, like generalized erythema multiforme, which sounds serious.
It is, yeah.
Huh.
Significant skin reaction.
Reported in 2 cases linked to black cumin oil, both from putting it on the skin and ingesting it.
Right. And there was also a case mentioned of a patient potentially developing linear IgA disease, which is an autoimmune skin condition,
Wow.
after applying undiluted tea tree oil to a piercing. Just one case, but still.
Yeah, still concerning. And this isn't just about personal use. Occupational contact dermatitis is also reported, affecting people who work with oils regularly, right?
Definitely. Like aromatherapists, obviously,
Oh.
physiotherapists who might use oils with eugenol, like cinnamon or clove, or
Mhm.
beauticians working with things containing citral, like lemon or lemongrass.
So, given all these variables in production and what happens during storage, well, understanding and trusting the composition data for essential oils is clearly a challenge.
It really is.
I can imagine. The document talks about analytical purity and potential adulteration. Sometimes analyses list chemicals that just shouldn't be there, like solvents or synthetic compounds.
Right. And this isn't always just, misidentification, although that can happen. The document notes that sometimes it's intentional adulteration.
Like adding stuff on purpose.
Yeah. For instance, it mentions large amounts of phthalates, which are synthetic chemicals, being added up until 2004 in some cases.
What phthalates from plastics?
Well, they can be used as plasticizers,
Okay.
but they were also apparently added directly sometimes.
Mhm.
Or it could be contamination, maybe leaching from plastic containers or even from disinfectants used during production.
Okay. So it's complicated.
Very. And while acknowledging it's highly unlikely for a known synthetic compound to actually be found naturally occurring in a plant,
Right.
the document doesn't rule it out completely based on the data reviewed, which just underscores the complexity of identifying exactly what's in that bottle.
What's truly impressive, though, is the sheer scale of analytical work mentioned in the book this document is based on. This guy, Eric Schmidt.
Yeah, the Schmidt analyses.
He analyzed nearly 6,400 samples of 91 different essential oils and 2 jasmine absolutes over, what, more than a decade?
Yeah, between 1998 and 2014, it's described as, and I quote, by far the most extensive set of essential oils analyses ever reported in the scientific literature. It gives a massive data set to understand typical compositions, though, as you'd expect, the number of analyses varied hugely per oil. Some had none reported in this set, like neem oil, while sweet orange oil had over 400 analyses.
Okay, so a huge resource. Let's maybe put a spotlight on a few specific oils mentioned in the source because they offer some particularly interesting details, starting with black pepper oil.
Okay, black pepper oil. It's got that, terpenic, aromatic, somewhat spicy and herbaceous odor, mainly produced in places like India, Madagascar, Vietnam.
Right. And what's striking here is the sheer complexity. Over 305 different chemicals have been identified in black pepper oils from various places.
Yeah, it's kind of mind-boggling. And some of the major ones like beta-carotene, sabine, delta-3-carine can be found in really high concentrations, but those concentrations vary a lot too.
The key takeaway here seems to be the incredible chemical diversity even within a single oil type.
Absolutely. Next up, jasmine absolute. Now, it's important to note this is an absolute derived from flowers using solvent extraction, which is different from a traditional essential oil made by distillation or expression.
Okay, so different production method. Got it. It's described as having an intense, flowery, slightly animalistic odor.
Yeah, that's the description. Long-lasting, too. Mainly produced in India and China.
And again, a very complex composition.
Oh, yeah. Over 270 chemicals identified in some Chinese samples. Key components include things like linalool, benzyl alcohol, benzyl acetate.
Okay.
The notable point from this document regarding jasmine, though, is the contact allergy incidence observed in some studies. One group of patients with dermatitis from fragrances showed a pretty high rate, 24%, positive reaction when tested specifically with jasmine absolute.
24%, that's quite high.
It is significant, yeah.
Okay, moving to lemon oil. You mentioned expression earlier. The international standard body, ISO, actually defines citrus essential oils, except for lime, as specifically produced by expression, like squeezing the peel, not distillation.
That's right. Cold pressing or expression. And the document notes that some industry practice involves steam distilling the residues, the pulp and stuff left over from the expression
Right.
process, and adding that distilled material back into the expressed oil.
Which sounds problematic, like
So,
cheating.
yeah, the document calls it an adulteration because the heat of distillation fundamentally changes the chemical composition compared to the original cold-pressed oil. It's not the same product anymore, according to the ISO definition.
Right. Alters the profile. Okay, spearmint oil is also interesting. There's an ISO standard for this one, too, listing expected ranges for key compounds like carvone and limone.
Yeah, setting quality parameters.
Hmm.
But here's a really surprising detail from the document. A study looking at patients with oral lichen planus, that's a chronic inflammatory condition that can affect the mouth.
Uh-huh.
In Australia, found that 5% of those patients had positive patch tests to spearmint oil.
Okay, 5%.
And for a significant portion of those, about 26%, the reaction was considered relevant to their actual condition. What's more, their OLP improved significantly, like over 80% improvement in 10 out of 14 patients, simply after they avoided spearmint.
Wow, so just stopping spearmint led to major improvements.
For most of them in that group, yeah. And it's connected to positive tests for carvone, which is a major component of spearmint, and interestingly also sassafras, which they thought might be a cross-reaction.
That's a powerful example showing a direct link between an essential oil and improvement in a specific medical condition just by avoiding it.
It really is.
Yeah.
Then there's vetiver oil, which has this rich history of traditional uses, particularly in India. Apparently, people make mats from the dried roots.
Oh, yeah.
And when sprinkled with water, they cool the air and provide this nice aroma, kind of like a natural air conditioner.
Oh.
And the list of traditional medicinal applications mentioned is long and varied. It was perceived as a stimulant, tonic, cooling, stomachic, diuretic, antispasmodic, used for fevers, inflammation, stomach irritability.
Also,
Yeah, and even specific tribal uses like root paste for headaches or toothaches, leaf paste for muscle pain, stem decoction for UTIs, leaf juice as an anthelmintic, that means expelling parasitic worms.
wow, quite the traditional medicine cabinet in one plant.
Seems like it. It's a fascinating glimpse into its historical role. Linoleic acid is mentioned as one component.
Okay. Finally, rose oil. The document notes over 25 publications reporting contact allergy to rose oil.
Right, and routine patch testing shows around a 1.6% positive rate, so not super high in the general tested population, but definitely reported.
However, the document cautions that reliable data on whether these positive tests are truly relevant, like actually causing the person's symptoms, is often lacking in general testing.
Yeah, that's a common issue in allergy testing. Relevance can be hard to pin down.
It does mention specific components like geraniol, citronellol, and linol as potential allergens in some individual cases.
Right, components within the rose oil. But it also notes that many positive tests happen when testing broad fragrance mixes and often affect people working directly with oils occupationally, like aromatherapists.
So, while allergy is definitely reported, understanding its true clinical significance in every single case can be complex.
Exactly, it's not always straightforward.
So, okay, what does all of this mean for you, listening, wanting to get a clear understanding without, drowning in all this detail?
Well, I think it really shows that essential oils, even the common ones we think we know, are incredibly diverse and complex. Getting that shortcut knowledge means appreciating the whole journey the oil takes,
Right.
from the specific plant grown in specific conditions through harvesting and processing, all those factors we talked about.
And understanding that the oil itself can change over time, potentially creating new compounds, maybe problematic ones like those allergens from oxidation.
Yeah. And it also involves recognizing the challenges and simply knowing exactly what's in the bottle because of analytical issues and, unfortunately, potential adulteration.
So it's not just lemon oil is lemon oil.
Definitely not. This deep dive, drawing from the details in this material, hopefully gives you those multiple perspectives: the traditional uses, the modern chemistry, the quality control headaches, and the health considerations like allergy.
Which is crucial for a thorough understanding, right? Seeing the whole picture.
Exactly.
Well, this has been a really fascinating deep dive into the complexities behind essential oils. Thanks for joining us.
And maybe we'll leave you with this thought to consider. Given the vast number of factors influencing an essential oil's chemical makeup, everything from the plant's genetics and where it grew to how it was processed, stored, and even how it was tested,
Uh-huh.
And given the potential for changes over time creating unexpected allergens, or simply the possibility of adulteration or contamination, how much certainty do we really have about the specific oil we might be holding or using right now?
Mm.
And what does that uncertainty mean for how we approach using them, and maybe how they should be regulated?
That is definitely something to think about. Until next time.